we are going to learn about concentration of solutions and what it means, what concentration mean, and what unit we have for concentration. For this specific video, we are going to talk about molarity. So before we go forward, we have to know some terms, okay? So the first one is solution. Solution is a homogeneous mixture of two or more substances. We talked about mixtures before when we were talking about matters, how to classify matters, and to classify matter by composition, we had mixture and pure substance. In mixtures, we have homogeneous and heterogeneous mixtures, okay? So when we have homogeneous mixture of two things, two substances, two or more substances, that's a solution. Solution could be gas, could be solid, or could be liquid. What we are talking on this video more specifically is the liquid solutions, but we also have gas solution. For example, from the definition, homogeneous mixture of two or more substances is a solution. So if you're thinking about a gas solution, what would be an example of that? Well, air consists of different gases, right? It has CO2, it has O2, it has nitrogen, so there are different gases and it's a mixture and it's homogeneous. So it's a gas solution. Or even if you want to think about a solid solution, you can think about a mixture of two different elements. Like if you mix iron with aluminum, and if you mix them, well, basically they melt them together and mix them and then they form a solid. So it's a solid and it's homogeneous, it's uniform, so it's a solid solution. Okay, so solution could be liquid, gas, or solid. uh, in this video we are talking about liquid solutions. Okay, so the next term is solute. Solute is a substance present in smaller amounts, so that's basically what is dissolved into something else. Okay, so that's the smaller amount is the solute. Solvent is the next term, and that's a substance which is present in the larger amount. Okay, so if you think about the example of salty water, okay, so you dissolve salt in water, right? So the salt that you're dissolving is your solute, and water is your solvent. Okay, so solvent is what substance that is the substance that dissolve the solute in itself. Okay, and we are going to talk more about water as a solvent, and any solution that has water as a solvent is called aqueous solution. Okay, so aqueous solution is a solution that has water as a solvent. So you have to know these three terms more specifically: solution, solvent, and solute. Solution is a mixture of these two, so solvent with the solute mixed together is the solution. Solute is the smaller amount, like in our example, salty water. The salt that you add to the water is the salt is the solute, the water is the solvent. The salty water is the solution. So what is the concentration of a solution? So if you think about the example of salty water, when you taste it, if it's very salty, it shows that it has lots of salt in the water, okay? So it's more concentrated. So the concentration shows how much solute is present in your solution, okay? If it tastes very salty, it means it has more salt in the water, so it has more solute in the water. If it's not that salty, it means the concentration is low, which means you have less salt in your salty water, in your solution. Okay, so generally concentration units shows how much solute you have in your solution, and it could be presented in different units. Okay, if you have the mass of your solute in, I don't know, the mass of your solution, that's 1 unit. You might have the mass of your solute in the mass of solvent. Remember those two terms. The mass of solvent, that's another unit for concentration. We have different units. So any unit that shows how much solute you have in your solution is a concentration unit, okay? The most famous one that we are talking about a lot in chemistry is molarity, okay? What is molarity? Molarity is the number of moles. So remember, concentration is how much solute you have. For this specific unit, molarity, how do we show the amount of solute? We show it with the moles, okay? So if you have the number of moles of your solute in a liter of your solution, and be careful, not solvent, but solution, the mixture of both of them, okay? So if you have moles of your solutes in the liter, the volume of your solution, that is called molarity, okay? So how can we find molarity? Molarity, you have to find the moles of your solute over the liter, the volume in liter of the solution. So let's have an example. So if you want to find the molarity of a solution, okay, so we are dissolving 5 gram, it's exactly the same example. So we have salt, NaCl, table salt, right? We have 5 gram of the NaCl, and we are adding to enough water to make 250 milliliter of solution. Something you have to be careful is that we didn't say we add 250 water, because molarity is the volume of the solution, okay, not the solvent. Water is the solvent. If we say we add 250 milliliter water, well, this 5 gram of NaCl also have a volume, so the total volume, which is the volume of the solution, is something more than 250, okay? So we add enough water to make 250 milliliter of the solution, okay? You have to be careful with these terms. So how can we find the molarity? So we know molarity, if we show it with capital M, is mole over volume, or volume in liter of the solution, okay? So what is the solute? The solute is the NaCl. Do we have the moles? No, we have the gram, we have the mass, so we have to find the moles, okay? How do we find the moles? How do we convert mass to mole? With molar mass, right? So you have 5 gram of NaCl, and you have to convert that to mole with molar mass. So I don't want gram, I want to get rid of that. I put it on the bottom and put the mole on the top. So you find the molar mass of NaCl, and you know that 58.44 gram of NaCl is 1 mole of NaCl, okay? So you can get rid of gram with gram and you have moles, and you have 0.08556 gram of NaCl, okay? Sorry, moles, okay? Moles of NaCl. So you have the mole. You need the volume in liter. Do you have the volume of the solution in liter? No, it's in milliliter, okay? So the volume is 250 milliliter, but I want it in liter, so I write milliliter on the bottom and liter on top to get rid of milliliter with milliliter. And I know 1 milliliter, always 1 goes to the prefix, and the definition, milli is 10 to negative 3, right? And the definition goes to the base unit. So it's 0.250 liter, okay? I write it this time, but you actually don't need to write it, because you're going to do it a lot of time when you're working with a molarity. Basically what you do is you move So let me write it again. So it was 250 milliliter, right? To make it liter, you move the decimal point 3 digits to the back, to the left, okay? So it becomes 0.25 liter. That's easy. But if you're not comfortable, you can just write it to make sure which direction you need to move the decimal point. Anyway, so we have the volume in liter and we have the amount of solute in moles. So to find the molarity, we have the moles of the solute divided by the volume of the solution in liter, okay, and mole over liter, that's molarity, and that is 0.34. It's a better idea to write molarity as mole per liter. You can either write or 0.34 capital M molar, and that's how we say it. We say 0.34 molar solution, okay, that's how we call it. Or it's easier, it's a better idea to write molar as mole over liter. So when you're using it in equation formulas, it's easier to just get rid of the units, okay? So to know what units you have to use. Mole over liter, it's the same thing, okay? Basically what we were talking about and the example we just had is how to prepare a solution. If you have Genchem Lab, or if you had Genchem Lab, that's how you do it. You try to find 1 molar solution of something, 1 molar solution of salt, for example, and you need 250 milliliter of a solution, okay? So you have to calculate how much salt you need in grams, because you cannot go ahead and, because you know mole is a unit for counting, right? You cannot go ahead and count the molecules of NaCl and see, okay, so this is 1 mole. You cannot do that. But you have balance in the lab, so you can easily weigh out the mass of your solute. So you have to find the mass of solute first, you weigh it out, you add it to your flask, and this is called volumetric flask, okay? Volumetric flask has a mark here that shows the capacity of that flask, okay? So if it's 250 flasks, so these marks shows that if you fill up a solvent in the flask up to this mark, that's 250, okay? So that's how they make the solution. So they weigh out the mass which is needed to make the for example 1 molar solution, and they add the salt or the solute, any kind of solute, to the flask, and they start to add water as a solvent. They add a little bit first because you need to have some room if you want to dissolve it, so you shake it, mix it, and do all those kind of things to make sure your solute is dissolved in the solvent, and then you add, so that's here, and then you add more solvent, in this example water as a solvent, until you have the meniscus, the bottom of the meniscus should be right on the line, okay? So it shows you have 250, and the last step, you just shake it a little bit to make sure it's homogeneous and the concentration is uniform throughout the solution. Okay, so here is one more thing that we can add to our tools for unit conversion. We talked about dimensional analysis, and I've told you that any unit which is in a ratio, can be used as a conversion factor, right? So molarity is mole over liter. However, you have to be careful. This mole is for the solute and the liter is for solution, and that's how I abbreviate solution, SOLN, okay? You have to be careful with that, but since it's a ratio unit, you can use it as a conversion factor. So if you want to go from mole to the liter of solution, you can use molarity. We talked about number of atoms in a molecule, so if you want to find how many atoms in one molecule, you can use a subscript, okay? For example, H2O, you have two hydrogen in one molecule of water. And we had these tools in the previous videos. So now we add molarity when you want to convert between moles to the liter of solution. So how do we do that? So let's see this example. How many moles of HCl are in 500 milliliter of 0.3 molar HCl? And that's how we say 0.3 molar HCl. Okay. So first of all, we have to know that it should be mole over liter, right? So this 500 should be in liter, 500 milliliter should be in liter, and we don't need to make it complicated, right? So we say for milliliter, it just moves 3 decimal places, okay? So it's actually 0.5 liter, okay? So we use the molarity as a conversion factor, and we start with the given information with the volume. So we have 0.5 liter. As a conversion factor, I want to get rid of liter, so I have to put liter here, and I need moles, so I put moles over there, okay? So molarity is mole over liter. So if we say it's 0.3 molar, it means it's 0.3 mole over 1 liter, right? That's true for all the ratio units like that. So we have liter, the bottom 1 liter is 0.3 mole, okay? So I can get rid of liter with liter, end up with moles. In this question, it's asking for how many moles. Sometimes you might be given a question that asks for the mass of the solute, okay? Not in this question, but I mean in general. So if you need the mass, you do not stop here, then you can use the molar mass. So you have moles, you want to get rid of mole, you want mass, you use the molar mass. 1 mole is the molar mass of that solute, and then you can go to the mass, okay? But we don't have that here, so let me erase this, okay? So that's how we do our dimensional analysis, and then we end up with mole, so we have 0.15 moles. So one common type of problems that you get in these concepts is the one that we already talked about. So you want to make prepare a solution of a known concentration, known molarity. First, you have to find the amount of solute in grams, because we have to have the mass because we have balance in the lab. So just the same steps we did in the previous slide. We did it until mole. If we need the mass, we do one more conversion factor with a molar mass to find the mass. Okay, we find the mass, we use a funnel and transfer the solute into the volumetric flask, and then we add water, shake it, dissolve it, and add more water until the bottom of the meniscus, which is the marking on the volumetric flask. Okay, let's have another example. How would you prepare 250 milliliter solution of 2 molar KOH solution? Okay, how do you prepare 250 milliliter of KOH solution? Okay, so it's exactly like the previous example. So we start with the volume. I know 250 milliliter is 0.25 liter, but even if you don't know that, you can start with 250 milliliter. That's also fine. That's why we use dimensional analysis, right? So we can have all of our conversions in one step. So I want to go from milliliter to liter. So I write milliliter here and liter here. 1 milliliter is 10 to negative 3 liter, okay? With liter, I want to go to moles. I can use the molarity. You know, molarity is mole over liter, right? So liter is on the top, so I want to get rid of that. I put it on the bottom, and mole on top. So it's 2 molar, so 2.0 mole is 1 liter, okay? So now I have moles, but I cannot weigh out mole in the lab. I need the mass, so I do not stop here. So I need the molar mass of KOH, and I want to get rid of mole, so I put it on the bottom and gram on top. So the molar mass of KOH is 56.1056 gram is 1 mole. Okay, are we done? So let's see. So milliliter with milliliter, liter with liter, mole with mole, and I end up with the gram of KOH. And let's write the subscript of KOH. It's KOH, the gram of KOH. Okay, so I know the mass of KOH. That's what we want. Okay, so if you do the math, just put these numbers in your calculator and you will get 28 gram of KOH. So how do you prepare that? You weigh out 28 gram of KOH, you add it to the volumetric flask. If if you accept this as the volumetric flask, it's a 250 milliliter volumetric flask. So you add your KOH in it, you weigh out 28 gram of KOH, and then you add water until you add water until you get here. Then you shake it, you dissolve the KOH, and then you add more water until the bottom of the meniscus is here, and then you shake it so you have a uniform solution, and that's your 2 molar solution.